Today, we are going to look at calculations in electricity. There is a law we use when solving calculations in electricity, and that is the law of microfaraday, which is popularly known as Faraday's laws of electricity. Okay, we have two laws of microfaraday. In this video, we are going to focus more on the first law of microfaraday. What did the law state? The Faraday's first law of electricity states that the amount of substance discharged or liberated during electrolysis is directly proportional to the quantity of electricity passing through it. Okay, the law states that the amount of substance discharged or liberated during electrolysis is directly proportional to the amount of current or electricity. This is measured in coulombs that passes through it. Okay, the law states that the amount of substances discharged or liberated during electrolysis is directly proportional to the amount of current passing through it. Okay, which is also described as quantity. Okay, it's the same, but we describe it as quantity in chemistry. Okay, the amount of substances discharged or liberated during electrolysis is directly proportional to the quantity of charge that passes through it. That is quantity of charge that passes through it. We have to, okay, the amount of substances discharged or liberated during electrolysis is directly proportional to the quantity of charges that passes through it. This does not mean that the amount of substance, this amount of substance is described as the mass. It can be the mass of substance. It can be the mole. Okay, it can be the number of atoms. It can also be the volume. Okay, it can be the volume, that amount of substance. Okay, so whatever amount of substance that is liberated, if it's measured in volume, you solve with volume. If it's measured in mole, you solve with mole. Okay, so whatever mass that is liberated is directly proportional to the quantity of charges that passes through it. Here in the calculation, we use mass to describe. Mass is directly proportional to the quantity of charge that passes through it. Okay, now this is the sign of proportionality. If you want to remove this, it becomes mass is equal to kq. Now this k is what? K is constant of proportionality. This is the constant of proportionality, the k. Then the m represents amount of substance, which we describe here as the mass of substance. But remember, it can be mole, it can be volume, it can be number of atoms, where we use Avogadro constant, which is 6.02 times 10 to the power 23. Okay, then the Q represents quantity of charge in coulombs. Okay, then if it is mass, it is in gram. This is chemistry, so we use the mass in gram, okay, when solving. Now this K that is the constant of proportionality represent the charge of the element used or whatever substance that is used, and this is where we are going to apply the electrochemical series, where you can now see the charges of every metals. Okay, here is King Nathan can manage or zone for since probably he caught Mercury against Peter Austin. We are not going to use platinum here for now, okay? Now this is K stand for king, N stand for Nathan, D stand for can manage all zones for since probably he got Mercury, which is hydrogenum in chemistry, then against Austin. King Nathan can manage all zone for since probably he caught Mercury against Austin. We have platinum here in some textbook, but I don't want to include it here for now. Now look at the charges here. Potassium is +1. These are the charges. Okay, so this mass now, this is mass equal to charge in the electrochemical series multiplied by quantity of charge multiplied by quantity of charge in coulombs. Coulombs is symbolized with capital letter C. Okay, so if you are working with aluminum now for the standard, because you have standard which you are going to compare with the questions, which is data of the questions given for you. Now the standard, you are working with aluminum, for example. Okay, the mass of 1 mole of aluminum is 27 against the charge of aluminum here is +3. Okay, you have 3 multiplied by 1 Faraday. This 1 farad in the quantity of charge is equal to 96500 coulombs. This is the standard constant. Okay, and it's going to be 27 gram. This is gram, okay, equal to 3 times 96500. Okay, remember that quantity of charge is equal to current in amperes multiplied by time in seconds. Okay, current in amperes multiplied by time in seconds. Okay, if you are required to find any of these data, for instance, if you are required to find any of these, for instance, and in the question, they must provide you with the actual mass of the element or aluminum here we have in the question. They must provide you with the mass of the substance you are using in the process, okay? And maybe you are required to find any of the two. If any of the two are required to be found, that means you are going to have one entity given for you in the question. Assuming you have 2.7 gram and the current here is 2 amperes and you are required to find time, okay, multiply this by time, it will give you what? 2t. If you multiply this by time, it will give you 2t. Then you have to cross and multiply. That is 2.7 multiply 3 times 96500, okay, equal to this multiply this 27 multiply 2 T. Then after whatever, you are going to divide by 27 multiplied by 2, divide this by 27 multiplied by 2, so that if this should cancel this your time will become equal to this. You solve straight. Whatever you now get is now the time it requires to discharge that mass of electricity in the question given for you. Okay, this is just to show you how to apply the microfarad first law of electricity. Okay, then this is for the mass. Then if you are required to find the volume, let me say you are working with the volume. Okay, now every 1 mole will give you the respective mass. Okay, now you solved here with aluminium. It's going to give you 27 grams of aluminium. Okay, then after that, if it's volume now, it's going to give you what? 22.4 dm cube. Okay, then assuming you are working with volume, for instance, it's going to give you 22.4 dm cube of aluminium. We are working with the standard now. Okay, this one here is the question given for you. Now, 22.4 dm cube against 3 farad. Okay, then if you are asked to find the volume that will be liberated with a particular given quantity of charge, you are going to make here your x. Okay, which you know that is already in dm cube. Whatever you get will be in dm cube. Then you are given something like 56,900 quantity of charge. You solve straight. Whatever you get will be the volume in dm cube that will be liberated by this particular mass of electricity. That is what microfarad first law is telling us. Okay, so we are going to stop here for now. In our next video, we are going to solve some of these calculations questions we have in the exam past question, and I will show you the simplest way to tackle it. Okay, don't forget this relationship. Okay, this one is the mole, this one is the mass, this one is the volume. Then if its number of atoms is equal to 6.02 times 10 to the power 23, then whatever that is given for you, if it's mole, you use mole against this. If it's mass, you use mass against this. If it's in volume, you use the volume as we have here against this. If it's a number of atoms, you will use it against this. Don't worry, in the next video, I will show you how to use this in calculation. Please don't forget to subscribe to our channel. Thank you and God bless you.